Hi, welcome to Easy Engineering. Today we're going to learn about air knives. So, what is an air knife? And when I'm talking about compressed air operated air knives. What they're used for is one, to replace drilled pipe or rows of nozzles, and they're especially useful when you need an even flow for blowing off, for cleaning, for drying any particular surface. Quite often, if you have a row of nozzles or even rows of separate flat jets blowing onto a surface trying to clean or dry them, it may not work all that well because the flow is not even. Certain types of material, certain types of surfaces require a nice, even, flat flow. That's what an air knife will do. It gives you a nice, even flow. Now, there are two styles on the market. The older style is this one here, where the compressed air comes out of a small gap, maintained usually by a shim. The compressed air goes into the air knife, comes out, and trains the air from the surrounding atmosphere, amplifying the airflow. And the air actually bends 90 degrees coming out of the air knife. Very, very prevalent, still in use a lot today, but it's an older style and not as efficient as the new ones. The newer ones, although they're not that new, they've been around well over 10 years now, is the compressed air comes out, again, from a small gap maintained by a shim, but the air comes out straight and training air from each side. When you compare the two styles, the newer style has about 25% greater efficiency. That's pretty significant, and quite often they're more quiet as well. But both are used on the market, and they have their uses. Okay? Now, what do you look for? When you have to choose a compressed air operated air knife, what is it that you look for? First of all, do not look for just the amount of CFM that it consumes, or the amount of air that it consumes at a particular pressure. You want to look at the force per CFM at a particular pressure, because the efficiency of the air knife is governed by the inside. Some air knives will consume a little bit more compressed air at a particular pressure, but also produce that much more force. So it's the force per CFM that defines its efficiency. Give an example. One air knife may produce a couple pounds of force at, say, 80 pounds pressure, consuming X CFM. But another air knife design can give you that same 2 pounds of force at the same CFM, but at a lower pressure, say 60 psi. So the air knife that's actually more efficient is the one that gives you that force per CFM at 60 pounds, not 80 pounds, because it takes less energy to create 60 pounds than it is to make 80 pounds from an air compressor. So don't look just for the CFM or the air consumption at any particular pressure. You have to look at the force per CFM at a particular pressure. That's what determines efficiency. So look for a good design for efficiency, force per CFM. Good manufacturing. An air knife looks pretty simple. A couple pieces of material bolted together with a shim on the inside. Not that easy. Imagine trying to machine something flat, especially a long length if it's stainless steel. Not easy to do for those of you who know how difficult it is to machine stainless steel. For aluminum, same thing. Try to machine a flat surface over a longer length. If it's not flat, and those mating parts are not flat, and the shim is not flat, you are not going to get even flow. So good manufacturing entails very, very tight tolerance, very, very tight quality control. Installing the air knife. Well, one more thing on the manufacturing. Material, the material used. If you're dealing with aluminum, you want to have the aluminum anodized. If anybody's ever looked at unanodized aluminum in a factory over a period of time, that aluminum doesn't look very good. It oxidizes, it looks terrible after a while. So anodized aluminum is going to look a lot better and last a lot longer. You want to have stainless steel screws if you can't bring the materials together. On the inside, that gap I had mentioned is usually maintained by a shim. If that shim is plastic, that shim's going to wear out fairly quickly, because no matter how much you filter the compressed air, you're going to get some dirt, some abrasion against that shim on the inside. If you have a stainless steel shim on the inside, it's going to last a lot longer. If you have a plastic shim on the inside, that's going to wear away pretty fast. So you want to have a metal shim on the inside of your knife if possible. So the material used, again, very, very important. When you install an air knife, a good design is going to have mounting holes. These designs in my hand have mounting holes on the back and on the bottom. So what that allows you to do is to have the installer put the air knives on the equipment without having to take off the screws that hold the air knives together. If you have an air knife where they have to take off the screws to install, that's not a good design. And the reason is this. Remember I mentioned you want to have a very, very flat surface on the inside, flat on the parts to be able to maintain even flow. You also have to have a very even torque on those bolts holding the pieces together on the air knife. You start having an installer take off those screws to mount it somewhere, you're going to have that screw put back. It's not going to have the same torque, it's not going to be an even flow, it's not going to work optimally. So a good air knife design is going to have mounting holes so you're able to install the air knife without having to take the screws out to install. Okay? So mounting holes are very, very important. Finally, when you actually have an air knife, quite often you have the option of having the compressed air come in from the back or from the end. A small air knife usually requires only one input, but any air knife 12 inches or longer usually requires input from either both ends or from two inlets from the back. It's either or. You cannot have inlets at each end and then the back at the same time. It is one or the other. If you actually have the air coming in at the ends and at the back, it kind of messes up the flow on the inside and you don't get an even flow. So it's either at the ends or at the back to be able to operate the air knives. That's how you use an air knife.